Hello friends, welcome back. Myself Amit. So from this session I am going to carry on with the MCQs on influence line diagram. I'd like to solve all types of MCQs which is very important in the examination point of view. Fine. Let me read out the first question. Before that, I had completed all the concepts in the previous lecture series. Like I have taken some 4 to 5 lecture series in which all kinds of concepts has been already covered. So now I am starting purely on the MCQs. Let me read out the question first. The given figure shows a beam with an influence line for a shear force and bending moment at a section 1. The value of shear force and the bending moment at a section 1 due to the concentrated load of 10 kilonewton placed at the midspan will be. See the question they have given the structure also. So I'm just drawing the structure. This is a structure which is given in the question itself. Fine. So the question is like this. That is, a 10 kilonewton of load, moving load, is moving from the point A to point B, and they are asking us to find, and they have given some section. Here the section is, this is called as section 1. Okay. At this section we need to calculate the shear force as well as bending moment. And it is given like this, that is 3 meter up to here in the question itself. And this remaining distance will be 9 meters. So the total distance is how much? It becomes 12 meters. So now the main motto is to find the shear force and bending moment at the point at the section 1-1. Okay. So for that, what I am going to do, okay, I am writing a shear force for this section. Shear force at a point 1-1. Shear force at a section 1. So section 1 is here. For this I need to write the shear force. So shear force sections comes like this. So this is the influence line diagram for shear force, which is already been explained in the lecture series. So what is this ordinate? The ordinate will become A divided by L, which is nothing but, A is nothing but 3, this distance 3 divided by L. L is total, that is 12. Okay, the complete distance is 12 meter here. In the same way, this ordinate is B divided by L, which is equal to 9 divided by 12. 3 divided by 12, it comes to be 0.25, whereas 9 divided by 12, it is 0.75. Now, how to calculate the value of shear force? For that, so the load is present here, 10 kilonewton load is present here. So I need to calculate the ordinate at this position. Okay, so in order to find the ordinate at this position, I am making use of the concept which is called a similar triangle concept. So what is the distance present here? The distance is 9 meter. The similar triangle concept is very simple. That, see, for 9 meters, okay, for 9 meters distance from this point, for 9 meters distance, what is the ordinate? Ordinate present here is 0.75. Then what is this distance? This distance, they are telling this is exactly at the center. The 10 kilonewton is placed at the middle span. So we can the total length is how much? Total length is 12 meters. So it will become 6 meter, and remaining here it is 6 meters. Is it fine? So for 6 meter, what is the ordinate distance? That means here to here the distance is 6. The ordinate distance is x. That is what we need to calculate here, where x is equal to 6 into 0.75 divided by 9. If you calculate this, you will get it as 0.5 will be the ordinate distance. X will be equal to 0.5. So this ordinate is 0.5. See, whenever if you come across this kind of condition, you need to make use of the concept which is called a similar triangle concept. That is very simple. If you take, this is 9 meter, right? For 9 meter, what is the ordinate distance present here? Ordinate distance is 0.75. And for 6 meters, what is the ordinate distance? That for 6 meter, what is the ordinate distance? Then you need to make use of cross multiplication, where 9x is equal to 6 into 0.7. So this is the concept and strategy you need to follow. I'm just rubbing it off. After finding this, you need to calculate the value of shear force and bending moment. Shear force at a position C is equal to load into ordinate distance. Is it fine? So how many loads is present here? Here there is only one load, where load is equal to 10, and corresponding to that load, the ordinate distance which we have calculated, which is equal to 0.5. So shear force at the point C will be equal to 5. So according to the question, the shear force is equal to 5. Then they are again asking us to find the bending moment. How to find the bending moment is very important here. See here, for this same question I am going to draw the bending moment at a point C. For that, the bending moment diagram will come like this. At a point, position 1, it will be like this. Now I need to calculate the ordinate distance. How will you calculate the ordinate distance? AB divided by A plus B. A into B divided by whole length. What is the value of A? Value of A is equal to 3. Value of B is equal to 9. Divided by total length is 12. The ordinate will comes to be 2.25. But the load is placed exactly upon the center point here. For this we need to again calculate the ordinate distance by same what I had explained to you in that similar triangle concept. If you calculate the ordinate, it comes to be 1.5. Bending moment at a point C will be equal to load into ordinate distance. Fine. So what is the load which is given here? 10, corresponding to the ordinate distance is 1.5, which comes to be 15. So according to the question, shear force is 5 and bending moment is 15. Fine. Okay, let me move on to the next question. See, these kinds of questions will be asked in the examination. You need to be thorough with the concepts and how to draw the shear force and bending moment, then how to draw the influence line diagram with respect to reaction, shear force, bending moment. That is the first thing you need to remember. The second thing is you need to calculate the ordinate. Third thing is corresponding ordinates with respect to similar triangle concept. Final thing is how to calculate the shear force or bending moment. That is nothing but the load into ordinate distance. This much if you are supposed to do, then it will be good. Fine, let me move on to the next question. Yeah, very interesting question. A uniformly distributed load of 30 kilonewton per meter and 4 meter length. That is, in the question they are telling there is one uniformly distributed load of length 4 meters rolls over the span of 16 meter. So this load is rolling over the span of 16 meter. So I am just taking a 16 meter span upon which this roll is moving, like either from left to right or right to left, and they are asking us to find the absolute maximum bending moment. In the yesterday's class only I had given one chart how to placement of load with respect to UDL for maximum bending moment, for absolute maximum bending moment. According to that, if I want to place, I need to place this load exactly at the center. I am just taking, this is 8 meters and the remaining distance is 8 meters. Is it fine? So I am placing the uniformly distributed load upon this position, and the total distance is 4 meter. Exactly at the center I am placing it, which is 2 meters, and again which is 2 meters. The condition is very simple. See, in the yesterday's class I given on chart. I'd like to show you the chart. Yeah, see, this is the chart that you need to refer for the placement of load. See, A and B, which is L by 2, L by 2. Exactly at the center you need to place in such a way that the distance A is equal to B. So in my condition, what the total distance is 4, exactly at the half 2 I am placing it. Okay, depending upon this chart, make use of this chart. So I have given all the charts. Okay, these charts are very important in solving the MCQs. I told you, please make a note of this chart. Fine, let me move on to that. I'm sorry. Yeah, now how to find the absolute bending moment, maximum bending moment is very important. I am drawing an influence line diagram for this. So influence line diagram, of course it comes like this. Let me take this as a point A, B, and this point as C. At this point C it will be a maximum bending moment, and here the load is uniformly distributed load is been placed. So corresponding to this I want a ordinate, corresponding to this again I need a ordinate, and here so this ordinate will be AB divided by A plus B, which is nothing but 8 into 8 divided by 16. Is it fine? 8 into 8 divided by 16. The value, this value will be it comes to be 4 units or 4 meter. If you make use of the similar triangle concept, this comes to be 3 meters and this comes to be 3 meters. Finally, in this situation, I am just shading this area. Bending moment will be equal to load into shaded area. In case of uniformly distributed load, you need to shade the area which is below the uniformly distributed load. But in case of what we call as point load, the load into ordinate distance, that is the difference between these two things. So what is the load which is given here? The load is just a minute, the bending moment, 30 kilonewton meter. I forgot to mention here, it is 30 kilonewton per meter, which is given in the question. So load is 30 into shaded area. By making use of the trapezoidal formula, I am going to calculate this. So I will take this as one trapezoid and this as one more trapezoid, but both the trapezoid is same, so I am taking one trapezoid and into 2 I will do. See, that is equal to, for trapezoidal formula, it is how much? This is 3 and this ordinate is 4. 3 plus 4, this ordinate 3 plus 4 divided by 2 into, what is this distance? This distance is 2 meters. Okay, this 3 plus 4 divided by 2 into 2. Okay, but there are two sets. There are like two sets, one trapezoid and two trapezoid. So I am making into 2. If you calculate this, the bending moment will be equal to 420 kilonewton meter. This is how we are going to calculate the influence line diagram with respect to bending moment. So answer for this is, see, here they have given it is 420. Fine. Let me move on to the next question. Yeah. See, this kind of questions I had solved in the previous lecture series, exact previous lecture series of this. I had solved this. See, the solving is this is very much important here. I'll show you how. I'll just write down the structure here. This is the internal hinge is given. Internal hinge is nothing but it acts like a scissor. I had already told you. If there is an internal hinge present here, either it bends like this or it bends in the upward direction. It is nothing but a scissor, which I had already told in the last class. Okay, so the structure is given like this, and here it is C, point A, B, C, D, and this is the point E. In the influence line diagram for reaction at C for the beam as shown in the figure, I need to write the influence line diagram for reaction at C. Since it is a reaction at C, what I am going to do? I am going to apply a 1 unit rotation at a point C. See, since this is a point C, I am going to apply 1 unit rotation. Okay, so next, drawing the influence line diagram is very much important here. It comes to be like this in such a way that here this is 1 unit, here at a point D it ends. But since there is a presence of overhanging beam, it comes to be like this and it comes to be like this. And here, since there is a presence of what we call as internal hinge, it comes like this. Then at a point A, it is gonna end. Okay, how to calculate this ordinate? This ordinate can be calculated by making use of similar triangle concept. It comes to be somewhere 1.5. If you want, you calculate with respect to similar triangle concept. Fine. So the option B is the right answer for this question. That's all, guys. So remaining MCQs I would like to take up in the next session. Thank you one and all. Bye bye. See, for this kind of problems, I had solved many, like more than 10 questions in the previous conceptual lecture series. Go through that, solve all the things, so it will be very much important. See, this type of questions, it comes by practice. Okay. There is no more calculation method in this. The only with the help of practice, it will be very easy for you. Thank you one and all. Bye bye. Take care.